Is there anything you would like to review or double check?
You were talking about wired and wireless systems, so is there any difference between the transmission pattern of wired and wireless?
No. So here we had a picture of the network
Right.
stack. And given that the design is chosen in such a way that you only need to change one layer without affecting the others, then the answer to your question is that only the physical layer is different. Everything above is the same.
Mm-hmm.
This allows programs not to care about wireless or wired because it's taken care of at the lower layers of the network stack. What are your other questions? Okay, so let me get back to this protocol. You send your request, and you can indicate multiple parameters for the request, and according to the protocol, it is stated that to mark the end of your request, you have to send this sequence repeated twice. So you send something here, it ends with a \r\n, and then you send another \r\n on its own line without anything else. So as soon as this is received by the server, it scans the entire string, it finds this sequence, two \r\n's one after another, and then it knows, this is the end of the request. Now I have to begin processing it. So what it does, and when I say now I have to begin processing it, on this diagram it's this little bubble here. And different things happen. So it first of all checks this path and sees if it's valid or not. If it is, it probably needs to open this file, read it into memory, and then prepare that buffer for it to be sent back to the client as a response. It can also analyze all the other arguments given in this request. For example, it can see that the user agent is Opera, or no, let's say it's Internet Explorer. And the people who wrote the website, they know that, well, if I want to use this nice rounded corner, it's not going to work in the Internet Explorer. So let me send another type of page instead. So that's one other thing that happens. And if you read the RFC, you will find that there are a lot of things you can specify here. For example, have you asked yourselves, how do some sites know when you open them that you want not the English version of the page, but the Russian one or the German one? They know it because the protocol indicates that in your request you can specify another argument such as accept language, followed by the codes of the languages which you understand. For example, in my case, I usually do this: English, Russian, Romanian, and then everything else. So if the site has an English version, it gives me an English version. If it doesn't have this one, but it has a Russian one, it gives me the Russian one. And the cool part about this is that it can automate certain processes. So I don't have to open the site and then look for a flag or a language marker. It all can happen automatically. So that's the beauty of the protocol. It lets you do many, many things which help people get things done faster.
Does your browser send the language options?
Yes, the browser does this automatically. From our perspective, you see this as some kind of a configuration panel where you go and you make a list of languages which you understand. And then the browser takes that information and transforms it into something like this. And every time you send a request to the web server, this line is included. There are other examples you can use here. For example, accept encoding, or I think it's accept code page. I'm not sure exactly. Basically, I can say that I support Unicode, or I support code page 1251. Do you know what these things are? These are different ways to represent text, basically. And
Yes.
if you don't set the code page correctly, you will see some mumbo jumbo. Some characters will not be rendered properly, or you will see something that doesn't look like a human language at all. Just some dollar faces, percents, whatever. Yeah?
Where can we do the setting changes of this in Internet Explorer or Chrome or anything? Any idea?
I can show you. I don't remember the exact path, but just click on settings, then options, then configurations, then languages, and you'll find it. But yeah, we can do this after the class. We can run a short demo of that. And so that's it. That's how HTTP works. All you have to do to communicate with the web server is to know how to form this request, which format it must follow, which conventions must it comply with, such that the server will be able to handle it correctly, and then give you back a response that you can use to display a web page or draw a picture of a cat on the user's screen. And do you know HTML, at least briefly, superficially? So when you retrieve a web page, you see the text itself. You see bold, italic, pictures, alignment. But what the computer sees is just HTML code. So when I send the request for this page, the server returns me the HTML code that corresponds to this address. Then the browser, oh wait, I think it's not HTML but body. Anyway, the browser analyzes it and it looks for other tags such as IMG, which indicates that there is an image there. So then it makes a list of such things. Each image has another path in it. And then there could be some flash video, which also has a path in it. So what the browser then does for all of us automatically is that it sends another GET request to the server, and now it says, okay, give me this image, then give me that image, give me this flash thing, give me that flash thing. So it repeats that for all of the elements in the web page, and then it assembles it all in one nice picture. But if you look into the process, what happens at the lower levels, then for every element, there is a separate request between me and the server. So this is a very high-level, short, quick introduction to HTTP. And this is already enough for us to discuss several examples of application layer attacks. One typical example of such an attack is called an overlapping ranges attack. You probably use this feature in your lives. When you download a large file and the connection breaks, you can then resume the download from the spot where it stopped instead of downloading from zero. How does the browser know how to resume, at which point the download must restart? It does it in a very simple way. So initially, as you begin downloading the file, it's writing it piece by piece to your hard drive. And then let's say at this point, the connection got broken. So next time the browser sends a GET request, it introduces another argument in this list. And the argument is range. And let's say I downloaded 50 megabytes. So I need to download from megabyte 50 onwards. So the range indicates that I copy from 50, so 50 megabytes multiplied by 1024 kilobytes. So 1050, and then another 1024 to get it in bytes. So let's use n. So what the browser does is it sends a request that contains an argument that says, send me from bytes n to, and then if you read the protocol, the syntax indicates that you can write just n dash and then nothing else, and the server interprets that as, they want all the bytes beginning from this one and to the end. Or you could write something like range from 50 to 100, and it will only send you the bytes between this and this point. So it's a very nifty feature, especially for people that have very slow and very unstable connections. Again, yeah?
Some sites, they say that we do not support download resume.
Yeah.
Yeah, some
They
sites
do it
don't.
intentionally, so you can pay, for example.
This feature has been, like I told you, the protocol has had multiple revisions. This feature is supported as of HTTP 1.1. It's not present in older servers that implement the old version of the protocol. Some people can choose to disable it just because they can. So it's up to them. Normally, it is better not to do that because this way you can save traffic. Imagine though, in this case it's just 50 megabytes, but imagine that you're downloading a 500 gigabyte file and the connection got broken at the 499th gigabyte. It will be a shame if you had to re-download from scratch, right? So that's where it comes handy because megabytes come at a cost. Everything is coming at a cost. Energy, bytes, bits, gigahertz, everybody has to pay for it eventually. Now another thing the standard does is that it allows you to indicate multiple ranges. This would be handy in the case of, for example, a PDF. If you have a very long document and you have scrolled from the first page to page number 50, then the browser can tell the server something like, give me the interval from 0 to 100, then from 200 to 300, and then from 500 to 600. So the server will then read 3 chunks from the file and send them to you like that. So basically, you give a series of ranges because the syntax of the range attribute lets you do that. So one day, somebody figured out that there is a very easy way to make the server perform a very expensive operation with very little investment for me. So what they did is they wrote a program that creates such a request, and it generates such a range that looks like this. So range colon, give me bytes 0 to 1, then 0 to 2, then 0 to 3, then 0 to 4, and so on. So they make a very, 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 very long string, but it's legal according to the rules of the protocol. Because at the time they wrote that protocol, they wouldn't expect that people would do this kind of abuse. But somebody thought, hey, let's try to push this to the limit. So this attack is called overlapping ranges because it gives you all the ranges begin with the same point. Now, if you think about the way this is implemented in a web server, this would effectively force the serving application to read the same parts of memory into multiple slots in its RAM. So let's say you have 4 gigs of RAM, and normally what happens is that this, if I have, let's say, 100 kilobyte file, this file is read from the hard drive into RAM, and it's taking that space for as long as the information is being sent to the client. Once the information is sent, the connection is broken, and this memory can be freed and used for other purposes. But since I gave them such a wicked range, first of all, even if the file is just 100 kilobytes long, there will be multiple chunks in RAM that contain pieces of this file. So effectively, it will use much more memory. And the second thing that this person can do, again, the protocol says that the server keeps the connection open for as long as the response is being in transit, and then it breaks it. Now, what we did here is we forced the server to use a large amount of its memory. The second step of this attack is to read the server's response at a very slow pace. So remember this. I read it from the hard drive into RAM, I send it, and once it's sent, I erase it from my memory and I can do something else with that memory. But because my client, that is the person or the browser that sent me this request, is very slow, and it can only read my response at, let's say, 1 byte per 5 seconds, then I will be forced to keep this information in my RAM for a much, much longer period of time. Now, all you have to do is establish a number of connections, all of them forcing the server to read this multiple times, and with very little effort, I can use up the entire capacity of the server like this. So this is one example of an application layer attack.
Is this a DOS attack, or can it be built into one?
Yes. Basically, a DOS attack is a denial of service attack. It doesn't matter how it works, what matters is the effect. And the effect is, for as long as this thing is in progress, somebody else who connects to the server and sends them a normal request will not be able to get their answers, because the server is busy serving my not so orthodox request. Let's go back to the network stack. Typically, denial of service attacks happen at the transport layer. And for them to be effective, you need to have a large number of computers connected to the same server at the same time. So that's why you need a botnet, something which has thousands of computers that are controlled by the command of an evil genius person, for example. That person
How to do that?
tells those computers, hey, connect to this server and keep doing this every second. And now when you have this large amount of clients sending requests to a server, the server begins to have some difficulties, because every server has an internet connection, and you can imagine that the internet connection is like a pipe through which some water flows. If this pipe has a diameter of, let's say, 50 centimeters, then each time I am sending a stream of water, it gets filled up. And if I have many simultaneous connections at the same time, the pipe is full, and there are more requests, but they don't fit in. So the server cannot handle it. You can deal with this problem by getting a bigger pipe, but then it's just a matter of time. For me, a bigger pipe means that I need just more computers in my botnet, so I will be able to fill it completely, even if it's bigger than it used to be. Besides that, a bigger pipe would cost you much more. You need more expensive network equipment. You need to pay to your internet provider, because internet isn't free. Even if we do get it for free here at the university, at some point somebody has to pay it. So there are constraints. Usually you can express them in terms of costs. Yeah.
In the overlapping ranges, is there a way to protect against it? Like Apache, is there configuration in Apache, for example?
Okay, so first of all, let me I will answer that question, but first I will give you more things here. In a transport layer type of attack, the principle is quantity. You just have huge numbers of bots that do this at the same time, and the target simply can't handle it. But application layer attacks happen at a much higher level of abstraction. So in this case, it's not about quantity, it's about quality. So what I did here is I sent them a completely normal, legal request according to the protocol. It's just that I pushed it to the limit. Now, sending this string is going to be very cheap for me because, so 0 to 1, 0 to 2, 0 to 3, and then you repeat it multiple times. And this will be, let's say, 100 kilobytes, for example. So for me, it's an investment of sending 100 kilobytes. For the server, the impact is that it has to allocate a lot of RAM and keep it there, unavailable to others, for as long as I keep reading the response. Yeah?
So just because of those commas that you have put there, does that mean that that particular browser, that particular client will have to complete all those the ranges mentioned in that comma and then move on to the next client or something like that?
Well, it depends on how the server is implemented, of course.
I mean, suppose if there are two people, like me and her, and we both are viewing the same website, so we connect to the same server, but I have like 20 ranges and she has only one. So, and I connect first and she connects after me. So the server will first complete all those 20 and then move on to her, right?
Aren't there like various styles of operating?
Like
Like where you
first
have a
in,
round
first
robin,
out.
or it can be a priority based?
Okay, so the answer is it depends.
Yeah.
It depends on how the server was configured, which server it is, how many processors you have. Does it have multiple cores or just one? Does it do multitasking or does it not do multitasking? So I can't give you an exact answer other than it depends.
Okay.
But what you do, oh yeah.
So then I'm a bit confused between how that range actually depends on the memory, because if at all it's a round robin, like I just take 0 to 1 and then she connects, and then so this goes on to her, then she connects, so that particular chunk of memory will get freed, right, and it will be allocated for her, right?
So most likely the implementation of the server will be as such. It will have multiple chunks in RAM, one of them allocated for your request, another one allocated for her request.
Okay.
But what you do, besides sending just one request of this type, you send multiple. So even though she exists with her normal request, after a short while, your not so good ones will completely exhaust the resources that the server can allocate for others.
So you said for overlapping ranges, you don't need a botnet? Or you
No, you don't. So that's the beauty of it.
Okay.
With this attack, with this type of attack, I can bring a server down having a very slow dial-up connection. It only takes a small number of such requests to make the server reach its limits. And again, it's not about quantity. So in this case, my request will take just this much from the server's internet connection. The trick is not in the fact that I am consuming all of its bandwidth. The trick is in the fact that my requests are crafted in such a way that they will force the server consume more resources than it would normally be ready to give to people.
So like DDoS, you can fill up the memory of the server. This is one type. You can fill up the network
Bandwidth,
bandwidth.
that's another type.
Maybe
yeah.
the processor. Is this a way? Other types?
Yeah, so let's think about that. Another thing, so there's accept encoding, and there should be another one which I forgot the actual name, but the idea is that you specify in which format you like your data to be served. And you can tell the server, for example, that I want to use gzip. Basically, it will force the server to compress the response before sending it to you. Now, compression comes at a cost in terms of CPU cycles and RAM. So if you want to make your attack more elaborate, then you have to use a lot of other fancy requirements here, which would make the server do more before it sends you the response. So yes, you can manipulate it in such a way that it does more. Yeah.
So in case of the overlapping range attack, so that's entirely legal, right? Like you enter such a request, it's going to be entirely legal. But then how do you prevent such an attack? Because you know it's entirely legal and people wouldn't be able to.
Okay, so maybe you can generate an idea on your own. Lynn, how would you protect?
Maybe time session out. Serve one.
Yeah,
Serve one
that's
client.
one good way of doing it.
Okay, other ideas?
You know, I'm basically still confused between the range and its memory mapping because I really don't understand how why
Okay.
does the server just doesn't move on to the next
Because it's one
person.
process. It's one process.
Let's
It's one process.
do it like
That
this.
much.
Assume we are writing some kind of a program in C. You do this. F open, path to some file. You're doing this.
Yeah, yeah.
Okay, so I have some kind of a file pointer. I open
Okay.
the file, then I do F read this file, and read 50 bytes.
Okay.
And this is stored in some buffer, let's call it buff1. So if I read 50 bytes, this buffer will be 50 bytes long. Now, when I read the next chunk, I need to do the same thing. Open the file, then do an fseek to move the file pointer to where the range begins, then read another series of bytes, and this goes into another buffer. And then another buffer.
Okay.
So this effectively, even though, let's say the size of the file is just 100 kilobytes,
This
but
makes it more. Okay.
because you read it by chunks, it
makes
takes more space.
Okay. Fine.
And these buffers will stay busy. I mean, you cannot call the free function unless you have completely send the response. So like I told you, once you send this super duper request, read the response at a very, very, very slow
Yeah,
pace.
I understand now. So basically, whatever you do, how much ever you, even if she's connected or she's connecting, it doesn't matter because I'm just going on using the memory.
Yeah. So
Okay.
for the first stages of the attack, other people's requests will be served, but as you proceed consuming more and more gigabytes, you can't have enough of those.
Yeah.
Yeah.
What's the difference between overlapping ranges and the stack and buffer overflow?
Okay. So an overlapping range is an application layer attack which relies on the rules of specifying ranges in the HTTP protocol. A buffer overflow is a different type of attack which doesn't have anything to do with networks or with HTTP. Okay, let's do this. I can give you some analogies, but that would cause a deviation from this discussion. So let's do this first, and then if we have time, or maybe we can meet on another day, or when I walk back to Mary Gates Hall to return the camera, we can talk about it. So this is one thing about overlapping ranges, and you asked how to protect from them. So one method is very simple. If I were a server, I would not accept requests that specify more than, let's say, 3 ranges in the same request. If there is more than 3, I think 3 should be enough for anyone. Make it 10, but not 1,000.
This is like a web server configuration, right?
Yeah. It is not guaranteed that your web server has this option. So if it doesn't, you have to probably write your own plugin or make a patch if it's open source. But the idea is the following. So you just know that at some point you have to restrict the number of ranges. And this is how you would be able to protect yourself from these attacks. Now, another thing is that when you form this request, it is expressed as some string of bytes. And this string has a length. And according to the rules of the protocol, I have to keep reading the request until I reach a sequence of \r, \n, \r, \n. Now I can reconfigure my server in such a way that if I've been reading the request and I reached, let's say, 500 bytes, and I still haven't encountered this sequence, I'm just going to disconnect. That's it. So how did I choose this number? I just pulled it out of my sleeve or out of my hat. But what you could do, you could, for example, observe the logs of your web server for 1 month and see what's the average size of the request you normally get. And let's say that number is 400 bytes. And then you just add some delta, just in case, and configure the server such that if you get anything more than 400 plus delta, consider it as a bad thing. So just disconnect it. This way, you break the attempt to attack you before you are forced to load all of that stuff into RAM. Another thing you can do is sacrifice slow clients. But I'll switch to that when I tell you about another type of application layer attack. Do you have any other questions about this one? So the idea, again, I wish to emphasize, typical attacks happen here. This one happens up there. The measures I described, the defensive measures, must also happen here. Other attacks, the ones at the transport layer, you can defeat them by using some special type of firewall. For example, let's say you have observed empirically that in a regular denial of service attack, you are being attacked by computers from
Russia.
Moldova. I don't want to offend Russians, so let it be my country. And then you can say, you know what? Screw Moldova. And then you blacklist the whole IP range at the transport layer. So one's attempt to connect your server will be rejected even before you got to open your mouth and send the first G character of your GET request. Because the only thing you need to know to protect from that attack is the IP from which it came. And firewalls operating at the transport layer, they're very common, they're cheap because now it's widespread technology, so everybody has one and everybody knows how to configure one. But these attacks are based on intimate knowledge of the quirks of this protocol. This device doesn't know about that. Remember when I told you about abstraction between and how one layer doesn't know about what happens in the layers above and below? So a transport layer firewall doesn't care about the fact that this string has many ranges in it. Because from its perspective, this is just a bunch of bytes. Its job is to deliver these bytes from this point to that point, and then it's somebody else's problem to figure out what to do with those bytes. So application layer attacks are much more sophisticated. It takes a while to think about a way to create such an attack. So in the case of the HTTP protocol, one just had to read the RFC, check the syntax of the range parameter, and then ask the question, hey, what if I give them a very, very long range? Yeah. Now, let me switch to another type of attack.
Are you going to be showing us this?
You want to see a demo?
Yeah.
Yeah, it's on my computer, it's ready for use. So how much time are you still willing to hang out here?
I'm okay.
So I can show you 2 more examples because they're very easy, and then we can run a demo.
Okay.
So another attack that is very easy to implement is called a slow loris attack. A loris is an animal, a very slow moving type of monkey, something like that. And the idea is very simple. You make your GET request. So it has \r/n in the end, repeated twice, so all according to the rules. But when you connect, now let me change it. Slow post, so we don't use GET. You probably heard about this somewhere else. When you have a web form, or when you want to upload a file to the server, it's using a POST request. So a POST request, unlike a GET request, has the following form. So I'm sending the header, which has this, followed by the path where I want to upload. Then you can include some other arguments. One of them is